Hey, what's up guys? It's Drew Patel back with another video, and today we're going to be on the physics classroom, and I'm joined by
Shashaank, Joshi, and today we have a special new guest, Jason Lee.
I'm honored to be on this show.
Dude.
And today we will be reviewing the common misconceptions in physics in movies.
Alright, so let's get right into it. Our first clip is Flash. Alright, we're going to get straight into the clip. In this clip, as you can see, Flash is trying to save his best friend, Iris. He's traveling almost at the speed of light, which is around 482,000 miles per second. That is insane speeds. And if someone would ever try and travel with someone else traveling at that speed, you would die. You would have your neck broken, your spine would snap, and your head would fall off its body. That is very dangerous.
Okay, let's get straight into the clip.
Yeah.
I swear to God, that's so animated.
He's traveling so fast, as you can see.
Dude, she's dead. She would have been dead. Dude, she's dead. What is this, dude? Okay, he's dead. That's good, but...
It's a machine, Patel can't die.
Just looking at this clip, it's pretty obvious that the girl would die. And like, if the girl he's saving goes from rest to 150 meters per second, her neck would be snapped within nanoseconds, and her brain would also hit the back of her skull, which with such intensity that would cause the brain to swell and bleed. Essentially, it would kill her. And obviously, we know that Flash is going at incredible speeds, and anyone can see that she would die. But let's just assume that her head is cushioned by the Flash's body, and her brain hitting the back of her skull doesn't kill her. During the same time Flash carries her, her organs will be shooting through her body at 540 kilometers per hour because of the centripetal and centrifugal force acting on her.
Then she goes instantly from 150 meters per second to standstill when Barry Allen leaves her outside without showing any momentum from that motion whatsoever, which is impossible. In reality, this momentum would cause her neck to snap forward, break her spine practically in half, have sudden loss of nerve supply to the entire body, including the heart and blood vessels, suffer a sudden drop in blood pressure, and immediately go what is called a spinal shock. So basically, she would have been flat on her face, dead as soon as the Flash stopped moving.
So basically, she's dead.
That is why this clip is incredibly false, and Hollywood has many examples of this that we are sure to show to you.
Let's get on to the next clip.
A few moments later.
Now we have a clip from the popular Disney movie Up. In this movie, there's a house, a real house that is apparently flying with the power of balloons. We'll go right into this clip.
So as we can see here, the balloons are now getting released.
It appears to be hundreds of thousands of balloons, appear to be filled with helium.
That's not enough to like just lift the house. I mean, like, dude, the force of buoyancy isn't even that high with all of those.
And apparently the house appears to have foundation inside the ground too.
Yeah, the foundation's like much stronger than the force of the balloons, dude. This isn't even possible.
And I'm pretty sure even if the gas inside the balloon's still not helium, I'm pretty sure that any gas can still not lift this house.
I don't want to ruin any kid's childhood, but like, this is so unrealistic.
And the house just keeps rising. It's not like it's traveling at a level height. It keeps rising to hundreds and hundreds of feet.
So in this instance, the force of buoyancy would be stronger than the force of gravity.
Which we know is false.
Okay, this is pretty stupid. We're just gonna end the clip right here. I mean, like, let's just get into our explanation of this.
As we said before, the force of buoyancy on the balloons cannot lift the weight of the house applied by gravity.
And these aren't just theoretical statements. We have cold hard facts to back that up. So the average mass of the house, or in kilograms, is 70,000 kilograms. If we convert that into newtons, that's around 700,000 newtons that the force of balloons has to overcome.
And obviously, we know that the force of buoyancy created by balloons isn't like nearly enough to lift 700,000 newtons. We know, like, when we go to birthday parties, they have little masses, the mass things for holding down balloons. And we know that that's, like, such a little mass in comparison to the mass of a house. And, like, just knowing that that little mass holder can hold down a balloon, we know that the balloons can't even lift up a 700,000 newtons. So, obviously, this is just completely unrealistic.
Now we're going to move into our next clip.
Okay, so now we're gonna analyze one of our childhood favorites, Scooby-Doo. This is gonna be the season 1 intro, and we're gonna get straight into the clip.
So in this scene, he's
Oh, dude, what is he
right
doing?
there.
he got
Yeah.
scared,
Yeah,
so
dude,
he
let's-
jumped
Let's
up,
go right back to that. Wait.
and he was like running in place in air. And we all know that when you jump
Dude.
up, you come back
Yeah.
down.
According to
Yeah.
gravity, as soon as you jump up, you shouldn't be able to levitate for like a few seconds.
So gravity's a professor now, dude.
Yeah.
According to gravity, dude, the force of gravity, obviously, gravity's affected by every single object. So like, obviously, Scooby couldn't just be like running in place in midair. I mean, that's a pretty easy one to analyze. We know that the force of gravity, it's gonna be there, so he shouldn't just be running in place.
And this happens in many other cartoons, such as Tom and Jerry also.
So we're gonna get into the next clip. We'll see you then.
Alright, so now we are going to analyze the next TV show. It's called Coyote and Roadrunner. And just like the other example, we see how gravity does not affect the characters.
Okay, let's get into this.
So he sees that there's a bridge ahead, tries to stop himself.
He's about to fall off the cliff.
Dude. Oh, dude.
And right
Yo.
now, as he's falling off the cliff, you can see that he's sort of suspended in the air for a moment without falling.
So he's like in the same horizontal, like he's still in the same place, but like he doesn't go down at all.
Dude, what is this?
He's been there for around 10 seconds now.
Yeah. Dude, it looks like gravity's not even affecting him.
And he should probably die once he hits the water.
Yeah. So we're gonna get right into our explanation in a little bit. We'll see you then.
One eternity later.
Alright, so in this video, we can see that Wile E. Coyote is sort of suspended in air for a few seconds, around 10 seconds. That is very, very wrong, I guess, because gravity acts on all objects equally, and it is not possible for an object to stay in motion for a long time. So if we have this water bottle right here, if we throw it up, it comes right back down. It doesn't stop in midair. Drew will take over.
Okay, so obviously we also saw that the device that he was like going on also made it over to the bridge that was there, and basically we saw that the thing was going across it, and gravity wasn't affecting that either. And so we see that like a lot of the cartoons kind of like create this misconception among kids, and that like gravity doesn't work until like you look down in cartoons, which is kind of funny and a little bit amusing. So I guess we're gonna get right into our next clip.
Alright, so the next clip we're about to show is Dark Knight. This is one of the older movies. It was released in 2012. So in this scene, it shows the detonation of a fusion bomb just a few miles away from Gotham City, the center of the movie. With only 90 seconds to get the bomb away from Gotham City, Batman would have to travel at 290 miles per hour to get more than 7 miles away. Even at that distance, much of the city would have been incinerated.
Okay, let's gonna take a look at the clip to see how it is.
So this is Robin over here. And
Here's Batman trying to take away the bomb. Some scary music.
it's suspenseful music.
Yeah.
As we can see, Batman is going close to the bomb. The bomb is about to detonate.
There's 2 seconds left.
And then now the bomb has exploded. And as Shashaank said before, he has 90 seconds to get away from the bomb and to travel 290 miles per hour.
So bombs are usually they can be measured visually, so the plume of smoke that erupts from the bomb is pretty large, so it's a pretty strong bomb.
And obviously we know it's like a fusion bomb, so like even at that distance, like much of the city would have already been incinerated. So like, well, it's like we know it's not possible. Yeah, that's gonna wrap up our video for Bad Bits and Movies. I hope you guys smash the like button, subscribe, and comment down below.
We're gonna have some more videos coming up. Every new unit we have, we're gonna have a new video. We're honored to have a special guest this time, and we hope to have more people on our show in the future.
Shout out to Mr. Bushka, our revered instructor, and peace.